Everyone just needs to calm down. It's going to be okay. Things are going to work out eventually. I thought things were getting better, but apparently they're not. You know what? I'm not going to get into it because I can go on a huge rant, and this is not a political channel. Let's get into the video today. What is up, everybody? How's it going? Today we're going to be talking about doing the final setup for our compiler. And yeah, so this is going to be like the last thing that we need to do, and then we can kind of get into the actual compilation stage. So we've kind of gone over a lot. We're now in the backend folder. So we have to set up a few more things. We have to set up our scope, our reference pointer, and our expression. So let's start with the easiest one. Well, actually, reference pointer is the easiest one. Okay, so if you remember before, a reference pointer references data that it points to a specific set of data that is going to be accessed in some way in our programming language. So reference pointers can represent it can represent fields, functions, classes, whatever. It doesn't matter. The way it's going to work is we have this class of a reference pointer. You have your default constructor here. You have a free, of course, because you have a list of classes. And then it's going to contain our module that we're in, or the current module that we're representing, and then the class or the list of classes that we're going to be accessing. So the concept of how this is going to work is we're going to start out, right? And when you access anything in our programming language, there's a few formats. You can say, some class and some field or some function or whatever. Or you could do a hashtag, some module and do a hashtag and say, dot or some module hashtag some class dot some field. So because of that, we want to support this format by, saying, all right, do they specify a module here? In this case, if you did this where you just say some class dot some field, module will be empty and it won't have anything in it, and we'll just have two elements here of some class and some field. So not all these elements are assumed to be classes. It's just the way that it works, because the assumption is that when you're using dot notation, most likely you're going to be accessing static classes to access, certain fields or whatever. We'll see it later on. I don't really have to go too much into detail, but you want to set that up. After that, you want to set up your expression. So as we're processing expressions in our compiler, now this is going to be something we're going to use a while down the road. Like, we're not going to be using it right now. But again, like I said, I want to get this stuff out of the way. So what you want to do is you want to create what's called an expression type. Now, in my other compiler, I made it ridiculously complicated. One thing that you're going to start to see in my compiler, even though as complicated as it is, it's a lot of code. I try to dumb things down as much as humanly possible because it makes processing information a lot easier. Now, in my opinion, the only way for you to do this properly is to have your virtual machine built beforehand. So if you guys are going to build a programming language, you're in a catch-22 situation where you need to build the compiler so that you can know how to compile the thing that you're going to compile to run on your virtual machine. But you also need a virtual machine to then understand how to compile the crap that you need to, bring it down to the virtual machine. So it's a bit of a weird situation. Typically, what I do is I typically go about it this way. We're at the stage where we have all of our setup, right? So this is going to be the last set of video of our compiler. And we're going to start talking on Wednesday about how to actually compile our first thing. And that's all fine and dandy, but typically the workflow of how I would build a programming language is once I get to that point to where I'm about to start compiling the very first thing, I stop there and immediately start working on the virtual machine. Now, the reason why I'm not doing that in this tutorial series is because I'm actively working on the virtual machine and doing tons of testing in that side, like making that connection between the compiler and the runtime system is very complicated. So in an effort to just keep the YouTube series going on, we'll just get to it later. But sorry for the huge rant. Just like to explain things, to give you guys some context on why I do certain things. Anyway, so in our expression type, we're going to have a couple different types. We're going to have a null expression, because if you return null, then you have to know that. We're going to have a var expression, an object expression, a class expression, and a nil expression. Again, very simple, guys. Are we returning a number? are we returning an object? When we return an object, we don't know what the type is because objects are anything in our programming language. So we want to know that. If it's a class, then great, we can process a class. And if it's, a nil, then it's nothing, basically. And of course, we have undefined. And after that, you want to create your class that represents what an expression is. You want to create your default constructor. You want to create an init function, which all it does is just initializes the constructor. So we have a couple fields. We have what type of the expression we have, and it's going to start out in the undefined state. We also have, we create a new U-type, and the reason for that is because if you remember, each U-type has its own code base, and we want to segregate code bases between expressions because each expression is going to generate a certain amount of code. So you want to basically have each expression hold its own U-type. Now, this is where it gets into the memory leak that I was talking about before in a couple of videos ago. This is nice for code generation, but it's bad for memory because I just don't clear out all of the U types because there's a very disgusting way on how I deal with these types in the type system using expressions. So it makes it very difficult for me to know when to free up the U type because it may still be referenced at another spot in the code. And yeah, that's where the problem is. After that, we want to create or we want to set our AST to null. What this is going to be is it's going to represent where was this expression created. After that, you want to create a copy function, which is just going to copy data from a pointer expression, and you just copy the values. And of course, you call utype.copy, which we went over in another video. After that, that's it for expressions. Now let's look at scope. Scope is going to be a little bit more complicated. All right, so let's talk about block types. When we have scopes, or when we're processing scopes in our programming language, we're going to need to process various different points in the compilation phase that represent very specific processing constructs for our compiler. That is a very weird statement, and I didn't think that one through, but let me explain. So basically what that means is at the highest level, right? When we're at the global scope, when we're in the SRT global scope that we talked about before, where if you have like a global class, it gets created under the SRT global class, that's going to represent global scope. Class scope means that you, like, for instance, created a field in class X. Now, class scope does not have any constraints on how nested the classes are. So if you have like class X at the highest level, then you nest a class of Y, then Z, and then there's like a field. Those are all going to be considered class scopes. Restricted instance block is a very unique way for me to trick the compiler into thinking something's happening that's not really happening. What a restricted instance block basically is, in short, is it is a way for me to say, all right, I have this field called X, and this X field represents a string class. Now, because I have that string class, if I try to use dot notation call or the dot notation format on that variable, anything that I try to access in that variable must reside within inside of that string class. So the concept behind it is you're accessing an instance and you're restricting the access of that instance to a thing. So that's what that is. We'll go over how this works later on too. After that, you have instance blocks. These are going to be like constructors or just normal instance functions. And then finally, you have static blocks, which are static functions. Now, let's see. Okay, so did I do anything down here? Add block. Okay, so I think I did all that, but what you want to do is you want to create a data structure of scope, and you're going to need to create a couple different constructors. So you want to create your default constructor, and then you want to create your constructor where you pass in a class and a block type. Now, let's see what type of fields each scope is going to hold. Now, when we have scopes, as I mentioned before, when we create scopes, we are only going to create one scope for each context that we're inside of. We're not going to be creating multiple scopes for multiple, like for instance, if you have a function, right? And in that function, you have an if statement. Even though technically the code inside of that if statement is at a different scope level than the code outside of that if statement, we're not going to create another scope block because that requires us to basically drag over all of this information to that next scope block. So what we're going to do is we're going to do the path of least resistance and use one scope for each context. So if you're inside of a class, we're going to use one scope for that class. If we're inside of a function, Doesn't matter how many nested whatever it has, if statements, for loops, whatever, I'm going to use that same scope. So, and that's very important, by the way, because I've did this in my last compiler and it was a nightmare. So just trust me on this one. It's the better way of doing it. So after that, we also want to reset our scope flags. So that's going to just reset all these fields back to their default values. I'm pretty sure you can understand what the default values is by the types. So let's look at the actual fields. We're going to need to hold the block type. What is the type of our scope that we're inside of? The class. So this is going to represent the class that the scope is representing. So if we're inside of like an instance block, that's mostly going to be current function, but let's say we're inside of a, what was another one? Class scope, right? So if we're inside of a class scope, well, what is the class that we're inside of? If we're inside of an instance static block or a instance block or a static block, then that's going to be the current function that we're inside of. So it just depends on the scope type, which will depend on what data we access in this data structure. After that, you want to have scope level. Now, this is where it gets into us being able to control how things are accessed within inside of a scope. Each item that is created it's inside of a scope is going to have what's called a scope level, and anything inside of that scope level can basically access anything from that level backwards, meaning that if we're going to start out at scope level of 0, and as we go deeper, we're going to increase the scope level. Now, if you have a variable called x at scope level of 5, that means it can access anything from scope level of 5 all the way back to 0. It cannot access anything from scope level of 6 and beyond, if that makes sense. After that, we have is reachable. This is going to be a Boolean that's going to determine whether or not our code is reachable. So if you have like a, I don't know, a return statement and it's like right above an if statement, obviously that if statement is not going to execute. We also want to create a initialization check. I don't remember what that is, but just create that variable. We'll see what that is later. I'm pretty sure it's important. Actually, let me see what that's used for. Field is initialized, initialization check. Yeah, I have no idea. Just create that variable. I'll figure out what that is, and we'll go over it later. After that, you want to create a loop start label. That's going to be, okay, so this is where it gets into the circus that is jumping around inside of a function. It gets really complicated to do that. So what I ended up doing was creating what's called a start and end label for loops. So the way it works is each loop that we're inside of, let's say, this block is a loop here. So we have a loop. If we go, or if we say continue, we only care about the current loop that we're inside of, right? But then let's say, we have, some blocks that are nested, and then all of a sudden now we're inside of another loop, right? So we're nested like, what is this, 4 blocks deep inside this loop. So let's say they're like if statements. And let's say we say break here. We only care about, again, the current loop that we're inside of. So what we're going to do is we're going to pertain to whatever the loop label that we're inside of is and go to that label. So if we want to break, we want to go to the end of the loop. If we want to continue, we want to go to the start of the loop. And what we'll do is we'll just set the loop start and end labels here and store the old values in case we had a loop at a higher precedence. And then once this loop exits, or once we exit that scope, we reset the previous start and end labels of those string values based on whether or not there was a loop previous. Hopefully that made sense, but that's kind of the general concept of it. We also have a list of ASTs. This is going to be for us to basically backtrack our abstract syntax tree list to basically backtrack to figure out exactly what is going on in the compiler. Because like, let's say we have, why is my computer freezing? All right, let's just, okay, there it is. So let's say we have like a go to statement, and let's say we go to a label, right? Well, let's say this label, again, this is like where it goes into the Wild West. Let's say this label is inside of a try catch. So if it's inside of a try catch, obviously we could potentially have like a finally, N-A-L-Y, we could have like a finally block or something, at a certain other scope level. We want to basically inspect the entire abstract syntax tree list inside of our function to be able to determine whether or not we need to execute the code that is inside of the finally block. So there's that. We also want to, let me remove this. We also want to have a list of key pairs that represent our finally blocks. This is going to be a list of all of the finally blocks that we need to execute. Now, the reason why I have this AST list here, and I just mentioned about us using gotos to catch finally blocks. We'll go over this later. I don't want this video to drag, but basically, there will come to be some interesting situations where this list is not enough information. That's all I'm going to say. I don't want to, because I'd have to like look at the code to see why I did that, but there's a very good reason for it. Finally, we have lock blocks. So what this is going to represent is this is going to represent any blocks. Like if we have a lock statement, so if I go back to here, our example here, let's say this was a lock statement. And let's say this was also a lock statement, right? Now this is, one lock statement. We're nested 4 levels deep inside of this lock statement, and then here's another one. Well, what that's going to do is that's going to log both of these lock ASTs as blocks that we need to basically execute if we jump outside of the scope of that lock block. Now, we have to do fancy stuff to figure out how many lock blocks we need to execute. We'll go over that later, but that's what that is. So I think that's it. Yep. So that's pretty much everything for now. Now we're all set up and we're all ready to go for our compiler. So like I said, Wednesday, we'll go into all of the code for compiling our first thing. I have to start really figuring out, this is a lot of code to go through. So I'm really gonna have to be creative and figuring out how to actually explain all of this code. 'Cause there's so much crap to go over. So bear with me, guys. I might not be perfect with this. Like I said, I'm new to compiler development, and I actually don't think I'm that good of a teacher. You guys can let me know in the comment section below, but I'm doing my best for you guys. I just really like to help people and show people how languages work, like Java and Kotlin and stuff, because I think it's very interesting. So that's going to be it for today, guys. As usual, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you do, definitely watch, star, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about learning what I've been up to on a daily basis, you can head over to the remastered branch. And I write some pretty wordy commits, so you can get a gist of what I've been up to without really having to look too much in the code. Also, if you guys are curious about learning maybe some of the things that I've done in the past to the language or stuff that I'm looking to add in the future, you can head over to the docs folder and there's 2 main files. You can check out the change list file. This is going to be pretty much everything that I've done in the past to the language as far as updates and bug fixes. And the roadmap file contains all of that information as well as things that I'm looking to add in the future. Definitely consider looking at this file. This gives you a lot of insight to the language and maybe possible things that I'm going to be showing you guys in a later tutorial in the YouTube series. So that's going to be it for today, guys. As usual, if you guys are new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.